Namaste everyone. In this video we shall solve a question from surface areas and volumes. This question is asked in CFPQ, competency focused practice questions. I've made a video on how to download CFPQ from the CBSE website. You may please look into that video. It is available in my channel. Now let's come back to this question. So there is a container in which has a gray hemispherical lid of radius r. So the radius of the lid as well as the radius of the cylinder are both equal to r centimeter. It's from the figure it is evident that the radius of the cylinder is also r centimeter. In figure 1 it contains water up to a height of r centimeter. So let us say the container in figure 1 contains water up to this level. So the height of the water in the first container is given as r. So height of the water will be equal to r centimeter. Now h is equal to r centimeter. It is then inverted as shown. In figure 2. Now, what is the height of water in figure 2? Let's assume the height of the water in figure 2 as h. We need to find out what is the height of the water in figure 2. So let the height of water in figure 2 be h centimeter. Because it is given as r centimeter, the height also will be in centimeters. It is advisable to take centimeters as the unit of h. The container is inverted. So the volume of water will both the figures remain same. Volume of water in both the figures remain same. First let us calculate the volume of water. Now water being a liquid will take the shape of the container. So here water will take the shape of cylinder. So volume of water will be equal to volume of cylinder. Up to what height is the water present? Up to height r centimeter. So volume of cylinder of height h. Remember the water is not up to the brim, so that's why we are not taking the height of the cylinder, rather we are taking the height of the water, which is h, which is also equal to r as per the question. Now volume of cylinder is pi r square h. Here the value of h is equal to r, so in place of h I'll write r, so it becomes pi r cube centimeter cube. Because the radius and height are in centimeters, the volume will be in centimeter cube. So this is the volume of water. So what is the volume of water? Volume of water is equal to pi r cube centimeter cube. Now the volume of water remains same in the container in figure 2 as well, because the same container is inverted. Whatever water was present in figure 1, the same amount of water will be present. Now volume of water in figure 2 will be equal to volume of water up to or volume of water of height h. Now what is h? I've already told, it is the height of the water in figure 2. Volume of water remains same, so therefore volume of water in figure 2 will be pi r cube centimeter cube itself. Now how do you find the volume of water of height h? It is equal to volume of the container up to height h. This is pi r cube itself, but here volume of the container, observe carefully, volume of the container up to height h will be equal to volume of cylinder minus the volume of hemisphere. We need to take away this volume because this part or this region of this container cannot be filled with water, so that's why we need to subtract the volume of the hemisphere from the volume of the cylinder of height h. So volume of the container up to height h will be equal to volume of cylinder of height h minus volume of hemisphere So pi r cube is equal to volume of cylinder of height h will be equal to pi r square h. Why r here? Because the same containers will have same radius. What is changing is the height is changing. Now the height is not small h, it is capital H, minus volume of hemisphere as usual is 2 by 3 pi r cube. So we'll simplify this. This is pi r cube. From these two terms in the RHS, I can take pi r square common, h minus 2 by 3 r, h minus 2 by 3 r. As I have taken pi r square common, h minus 2 by 3 r will be left here. Now I can cancel pi and pi, I can cancel r square and cube. So I will be left with r is equal to h minus 2 by 3 r. So transpose this to the LHS. Minus 2 by 3 r becomes plus 2 by 3 r, that is equal to h. So what is h now? If you simplify this, it will be 3r plus 2r, it is 5r by 3. So what is the height of water in figure 2? Height of water in figure 2 will be 5r by 3 centimeters or 5 by 3r centimeters. So this is the answer. So the height of water in figure 2 will be 5r by 3 centimeters. So which is the correct option? 5r by 3 centimeters is there in option 2. So option 2 is the correct option here. Thank you for watching. Please subscribe, like and share. Thank you again.